Hello. Today we're going to be looking at how to solve problems involving angle measure, perimeter, area, surface area, and volume. So first, a couple definitions. Complementary angles are two angles whose sum equals 90 degrees. So if you see on the left here, a 60-degree angle and a 30-degree angle add up to 90 degrees. So these would be complementary. Supplementary angles are two angles whose sum equals 180 degrees. So 120-degree angle plus a 60-degree angle would equal 180. So these two would be supplementary angles. An example of how this might be brought up in a problem is shown here, where there's an angle A where you don't know what the degree of the angle is. So we labeled it X, and angle B, which we know to be 118 degrees. And we're told that angles A and B are supplementary angles, which from the previous slide, we know that means that angle A plus angle B should equal 180 degrees. So since we're given that angle B is equal to 118, we can substitute that into the equation. So angle A plus 118 degrees should equal 180 degrees because they're supplementary. Now we just have to do a little bit of rearranging to find out what angle A equals. So we subtract 118 from both sides of the equation to get angle A. And since 118 minus 118 is 0, and 180 minus 118 is 62 degrees. So we know that angle A is 62 degrees. And since angle A is X, this means that X is also 62 degrees. Angles are particularly important for the definition of a triangle because a triangle is defined to be a three-sided shape whose angles always add up to be 180. So in this example, triangle ABC has an angle A that equals 3x degrees, an angle B that equals x plus 10 degrees, and angle C that equals 90 degrees. So same as before, we know what all these angles add up to, which is 180. So we can write that down. Angle A plus angle B plus angle C all should equal 180 degrees. Now we can substitute what we know about these angles into this equation to try and solve for x. Angle A equals 3x, so 3x, plus angle B is x plus 10, so x plus 10. And angle C is 90, so we can sub in 90. And all of that should equal 180. And now we can group like variables together to simplify the equation. 3x plus x is 4x, 10 plus 90 is 100, and 180 is the sum total. So now, kind of like before, we just do a little math, subtract 100 from both sides to get 4x is equal to 180 minus 100, which is 80. So we divide both sides by 4 to find out what x is, and I'm just going to move to the side here because I don't have space. 4x divided by 4 is x, and 80 divided by 4 is 20. So x is equal to 20 degrees here. So new topic. Now we're going to learn about what perimeters are. Perimeters basically measure the distance around some sort of 2D shape. So in the case of a rectangle, the distance around a rectangle is width plus length plus another width plus another length. So you get 2 lengths plus 2 widths as the perimeter. A square is sort of similar, except that all the sides in a square are the same, so you're basically adding 4 sides together to get the perimeter. So the perimeter is 4s. And the perimeter of a circle is also called circumference, and it's given to be 2 pi r, where r is the radius, which is the distance from the center of the circle to the outer edge. You can also see it written sometimes as pi times diameter, or d, because diameter is the distance from one edge of the circle to the other edge, so that ends up equaling 2r. So feel free to pause here because we're going to move on to a practice problem. So what is the circumference of a circle with a radius of 2 feet? So from the previous slide, we know that the circumference or perimeter, and I'm just going to shorten that to be p, of a circle is equal to 2 pi r. And we're given that r, or the radius, is 2 feet. So we can substitute that into the equation to be 2 pi times 2 feet. Now we can just do a little math to make that cleaner. 2 times 2 is 4 times pi, and the unit should be just in feet. And so this should be the perimeter or circumference of a circle. So moving on to area. The area is the number of square units it takes to cover the shape of a figure. So for example, this region here would be the area of a rectangle, and we can get it by multiplying the width times the length, or one side versus the other. Similarly, in a square, you'd multiply one side times the other side, and since they're the same, s times s is also equal to s squared. The area of a circle is pi r squared, where r is again equal to the radius, and the area of a triangle requires you to know the base, which is the length of one side of the triangle, and the height, which is the distance from this tip all the way down to the base, where it's perpendicular, so it makes a 90-degree angle with the base. So you take the base, multiply the height, and then multiply the whole thing by 1/2 to get the area of a triangle. And again, feel free to pause because we're going to go into another practice problem. So what is the area of a circle when it has a radius of 2 feet? So from the previous slide, we know that the area of a circle should equal pi r squared, and we're given r equal to 2 feet. So we can sub that into the equation, pi times 2 feet squared. So 2 feet squared equals 2 times 2 times feet times feet. So 2 times 2 is 4. We're multiplying that by pi, and the units end up being feet times feet, or feet squared. So the area of a circle with the radius 2 feet would be 4 pi feet squared. Now moving on to volume. Volume is the number of cubic units needed to fill the inside of an object, or in other words, the space inside a 3D object. So in the case of a rectangular prism or a box, you would multiply the length times the width times the height to get the volume. And notice how the length times width is actually the area of a rectangle. So you're basically getting the area of this rectangle at the bottom here, called the base, and multiplying that by the height to get the volume. And the same sort of logic applies to a cylinder, where you get the height multiplied by pi r squared, and pi r squared is equal to the area of a circle, which is the base of this shape. So basically, you're getting the area of this part and multiplying by the height to get the full volume of this object. Now for a cone or a pyramid, you sort of start off the same way by finding the area of the base. So for a cone, that would be a circle. So that would again be pi r squared. You'd multiply that by the height, but then you'd also multiply that whole thing by 1/3 to get the volume of a cone. The same logic applies for a pyramid, except a pyramid might have a base that is a rectangle. So in that case, you do the same steps, multiply by 1/3 and the height of the pyramid, but also instead of using the area of a circle, you'd use the area of a rectangle as the area of the base. Finally, the volume of a sphere is 4/3 pi times r cubed, and r is again the radius. So what is the volume of a sphere with a radius of 2 feet? So we know from the previous slide that the volume of a sphere is equal to 4/3 pi r cubed. And again, we do the same thing. We put in r, the radius of 2 feet as r. So you get 4/3 times pi times 2 feet cubed. And like before, 2 feet cubed would be 2 times 2 times 2 times feet times feet times feet. So 2 times 2 times 2 is 8. And feet times feet times feet is feet cubed. So we'll just add that back into the rest of the equation here. So 4/3 times pi times 8 feet cubed. And now let's just add these two, or multiply these two numbers together. 4/3 times 8 is 32/3. Multiply that by pi, and the units are feet cubed. So that should be the volume of the sphere. Last topic of the day, or lesson, surface area. So the surface area is the total of all the areas that make up a 3D shape. So one way to think about it is to see, like, for example, in this cylinder, how could we make this cylinder out of paper, and what is the area of all the paper parts that we'd have to use to make this cylinder? So in this drawing, they break it down into, there's a top base, which is a circle, the bottom base, which is a circle, and then you'd have to wrap around these bases with a sort of rectangle shaped piece of paper and then if you added up the area of this circle, and this long rectangular strip of paper, then you would get the surface area. So in the case of a cylinder, we know that the area of a circle is pi r squared. That should be the area of this circle piece. And the same goes for the bottom base because it's the same circle. So how to measure this sort of strip of paper that goes around the cylinder, which is also the area of the strip of paper is called the lateral area because it's the areas that make up the side of the shape. So one, we know that this side, or first, let's unfold this, and it should look something like a really long rectangle. And we know that this side, which is this side on this picture, is equal to the height because that's also this side in this picture. So we know that that side is equal to the height. But in order to find out how long this rectangle is, we need to think about what it's wrapping around. So since this piece of paper is wrapping around the base, we know that the distance from here to here should equal the distance around the circle that it's wrapping around. And we know that the distance around a circle is its perimeter, or circumference. So we know that from one of the early slides that the perimeter of a circle is 2 pi r. So the length of this side of this really long lateral rectangle should be 2 pi r. And we know that the area of a rectangle is length times width. So we multiply 2 pi r times h to get 2 pi rh as the area of this lateral area. And that's also shown here. So just to get a little more practice with cylinders, here's an example where there's a cylinder with the radius 3 inches and height 9 inches. And to find surface area, we can break it down into its sort of different parts and then find the areas of each and add them together. So the two top circles are just the top and bottom bases, which we know are here and here. And then this rectangle is just an unfolded version of the rectangle that's wrapping around the cylinder. So since we know that the top and bottom bases are circles and the area of a circle is equal to pi r squared, we can solve for what the area of these bases are. We know that the radius is 3 inches, so we can add that into the equation. 3 inches squared. And then we know that that would then equal 9 pi inches squared. And we did this calculation in an earlier practice problem. And we know that, so that's the area of one of these bases. And we know that we'd have not only one, but two bases for the top and the bottom of the cylinder. So the total area of the bases should equal 9 pi inches squared plus 9 pi inches squared to account for both bases, which is equal to 18 pi inches squared. Now we can take a look at the lateral area. So we know that this part of the rectangle, which is this part, the width, is equal to 9 inches because that's the height of the cylinder. So we know that this side is 9 inches. And from earlier, we know that the long side that wraps around the cylinder is equal to the perimeter of the circle that makes up the base. So that should be the perimeter of a circle is 2 pi r. And we know that r is 3 inches. So we can plug that in and get 6 pi inches as the length of this side. Now we know that the area of a rectangle is equal to length times width. And so we can plug in 9 inches as the length and then 6 pi inches as the width, or vice versa. It doesn't really matter which order you go in. And so we can just do a little math. 9 times 6, 54, times pi inches squared. So that's how you get the area of this long rectangle, or the lateral area. So in order to get the full surface area, now we'd have to add all these together. So the area of both bases is 18 pi inches squared, and the area of the rectangle that wraps around the cylinder is 54 pi inches squared. So that equals 72 pi inches squared as the total surface area of this entire cylinder. Thank you.